So when you go with the partitioning, so there may be chances where you will get 0 bytes part file. Yes or no, Sulba? Suppose I'm doing a partitioning, okay, and I have set my partition is 100 partition, 20 is the partition, and I started processing the data. There may be a chance there are some empty output files may generate. There are empty output file may generate. How to suppress empty output files? There is chances. It's a common known issue. The known issue in the sense like, let's say you have 10 partition and you started emitting the data. There may be a chance some of the partition may not get a data. Some of the reducer may not get a data. If the reducer is not getting the data, what will happen? It will create empty partition. It will create empty partition data. So how to handle that? How to handle it? Any guesses? Any guesses? Nagi, Debashish, Sulba? Are you guys able to hear me? Nagi? Okay. Sulba, are you able to hear me?
Yes, Veera, I'm sorry I got disconnected in between. I'm sorry.
Okay. Yeah, it's okay. So my question is that when you are using a partitioning, you might have executed a program for 26 partitions. Like when you given a text input, and you want all the words which start with the A should store in a directory, I mean different output file. All the words start with the B should store in another output file. All the words which start with the C, it should store another output file, and so on, right? So we might have seen this exercise. We have seen this exercise before, right? So while you are doing a partitioning, while you are specifying multiple reducers in the Mapreduce framework, there may be a chance you may end up with empty output files. Yes or no? We may end up with the empty output files. Let's look at here. I'll show you. Are you guys able to see my screen?
Yes.
Okay, let me show you that. So how to suppress the empty output files? The question is now how to suppress empty output files. Any idea? How to suppress empty output files? Any idea, guys? How to suppress the empty output files? I mean, logically try to. For that, there is some output format called lazy output format. There is something called lazy output format. What this lazy output format will do? This lazy output format will suppress the zero uh, 0 bytes empty no creating 0 bytes file, creating the 0 bytes output file or empty output files. Okay, let's see that. So, let's load it. It will take a couple of minutes time. By the time you can go through your drive, are you guys going through these notes? All these notes? Are you guys going through this? You have all the details are there here. All the details are there. Suppose if you want to know about a multi-output format, yes, there is something here. So this is what I'm talking about. Lazy output format. So what is lazy output format to do? You just need to do lazy output format dot set output format class as this. You don't need to set the lazy output as a format. You need to set any of the format, whatever the format you are using, you set it, but you need to set a lazy output format dot set output format class. That class removes all your empty file creation, empty output file creations. So very pretty simple. Let me show you here. This is very simple example, guys. Here, as I shown you, multi-output format dot write, where you can write your key and value and the name of the file. Look at, guys, here, lazy output format dot set output format class and your job and the type of the input format for your job. The type of the input format for your job. And you'll find the output in the form of, instead of part-0 file, you'll find specific name. What are the name you have given in the your, you can hard code the name, or either you can hard code the name, or what you can do, you can um, uh, you can use the key as your file name. You can use a key as a file name if you go with a multi-output format. Okay, so let me show you in this. Still it is loading. By the time, let me show you how the in real time also it looks. Data flow, projects, vehicle metric, ATL, src, main, Java, com, Herman, SCP, metrics, aggregators. We'll just see Mapreduce. In the Mapreduce, if you see ETL raw mapper, if you see this also reducer. So multi outputs in the real time we'll use the multi output guys, because I'm just creating a multi outputs here. My key is a null writable, value is a text. Let's go back. Here initializing this, closing this. Yeah, multi output dot write. Yesterday this is what I was showing you. Yesterday this is what I was showing you. The write. We are not using context dot write. We are using multi outputs dot write, and type of the data. What type of data you are writing? What is your key? What is your value? And the folder structure. From here it's a folder structure. From here it is a folder structure. So the way you format is up to you. The way you format, that is up to you. So here I am formatting a specific a metric, like a specific metric, for in my case specific event. Under that a month. Under that I have something called folder. In the folder I will get all the files. That was my directory structure. So you can have a different directory structure. You can keep your the way you want to write. As I shown you, the multi output dot has the multiple ways of write method. Overload method. You can make use of the whatever you are looking for it. Clear. And here also, no, I think here it is not there. It is a plain yeah, here it is not there. Here just a plain right. Here it is context dot write. Any doubts guys about a multi output format? About multi output format? So we were talking about lazy output format. Let's look at here. One of the input format we have implemented it. It has that one of the file. I have implemented one of the job, but I don't know. And anyway, it's a pretty simple one. What you need to see that the lazy output dot set input output format, and you have to pass your job object and the type of the job. I mean type of the output format. Okay. So that's it about the multi-output format. There are other topics like let's discuss today about anyway most of them are not joined. So let's discuss today about something called compressions. Shall we discuss about the compressions? Let's discuss about compressions. Do you guys remember any compressions we have discussed before? What is a compression? Why we need a compression? Any idea? Anila, Debashis, Nagi, Sulva. Compressions. Compression. To reduce the size of file.
Process,
Mm-hmm.
yeah, process multiple files as a small file.
Okay, okay. And anything we have done before, any compression technique we have used in Hadoop before? Do we used any compression technique before in Hadoop?
That was Hadoop archive.
Yes, Hadoop archive. Okay, along with the Hadoop archive, there are some more compression techniques. Let's look at them. Compression techniques. There are multiple places where we can apply the compressions. One is input. It's in the HDFS. You can take that as a compressed input. Already the data itself is a compressed. That is the one place. Other one is the map output. Your mapper output you can compress. Other one is your reducer output you can compress. Okay. So you can take a compressed input as compressed data as input, or you can compress the output file, or you can compress the final output. So there are different type of compressions in supporting by Hadoop. Those are like bzip, gzip2, lzo, snappy, and Hadoop archive. Okay, I'll tell you that what is the benefits of the each and every one. So based on the requirement and based on our whether we're looking at the processing speed, or whether we're looking for the uh, save the more space, or what we are looking for, based on that we will go with the respective compression. Okay, let's look at here. So here file compression has a two major benefits. One is the reduce the space need to be stored, and speed up the data transfer across the network, right? So when dealing with a large volume of the data, both these savings can be significant, right? So either one, you are speeding up your speeding up your process, another one is a process or transferring the data, or other one is reduce the space, storing space, reducing the space. How much suppose if you zip the file, you can store less space, right? The same way here as well. So what to compress? So here, as I said, the input itself can be compressed, which is already there in HDFS. If the input file is compressed, then the byte read from the HDFS is reduced. If the input itself is compressed, you no need to read huge so much of bytes of data, right? You'll be reading a very less amount of the data, which means less time to read the data. This time conversion is beneficial to performance, the job execution, which will improve your job performance. If the input files are compressed, they will be decompressed automatically. The beauty of Mapreduce is you no need to tell how to decompress it. You no need to write any code to how to decompress it. Your Mapreduce knows it automatically to decompress and will process the data. That is called Mapreduce aware archives. Mapreduce aware archives. It means your Mapreduce knows it how to decompress, and your Mapreduce knows it how to process it. You no need to write any decompression logic for that, as they are read by Mapreduce using the file name extension to determine which codec to use. So there is something called codec classes. So based on the codec classes, it will uses the respective codec for decompressing. Let's look at the example here. The file is extended in .gz. It can be identified by the gzip compressed file. So gz means it's gzip compression, right? So it will use the gzip codec. It knows it automatically. And compressing the output files, as I said before, often we need to store the output as a history files. It means you don't want to use for a long time. Let's say you just want to take the results and you will not be using for the future, but you may need it because you don't want to run the same job again. So already the job is executed. Already the job is executed. You may don't want to execute it frequently. In that case, what we will do, we will execute the job and we'll compress the data and store it somewhere. If the amount of the output per day is extensive and we often need to store history results for the future use, then these accumulated results will take extensive amount of HDB space. That's what, right? If you keep getting storing the huge output of your MapReduce, whatever the output data, and you may end up with a huge data. So you compress and keep it. Anyway, the compressed data can be read easily. Anyway, the compressed data can read easily. Guys, try to remember Hadoop archive. While we're discussing, Hadoop archive is not a good way to compress the data. Why? We have seen some limitations. If it is a Hadoop archive, MapReduce is not aware how to process the data. It will process as a normal data only. Because Hadoop, there is no Hadoop aware of archive. Apart from the LZO, gzip, bzip2, and Snappy, other things is not aware by your Hadoop. There are something called different file formats like ORC file format, RC file format. These are all important, guys. So because we are dealing with a huge data, we should understand there are different file formats: ORC, RC, ORC, Parquet, Auro. These four are more important about the file formats. If anyone wants to make a note, please make a note. File formats are RC, ORC, RC, ORC, Parquet, Parquet, P-R-Q-U-E-T, Parquet, Auro, A-V-R-O, Auro, A-V-R-O, Auro. These four are the important file format. There are so many, but these are the more four no file format, well-known file formats. And coming to the compressions, there are four compressions: bzip2, gzip. Gzip means gunzip. Let me write here. Gzip, bzip2, gzip and bzip2, LZO, Snappy. These are the well-known compression techniques. And coming to file formats, RC, ORC, Parquet, Avro, Avro. Okay, try to remember guys, these are the more important. We will be using them in the real time. Okay, let's finish the compression, then we'll see the file formats later part of time. So no need. So you can compress the final output and also compress the map output, intermediate data. So even if your Mapreduce application reads and writes the uncompressed data, it may be a benefit from the compressing the intermediate data. What is the benefit if you compress the intermediate data? The number of output. So the you can reduce the number of data processing through a network, because your reducer has to launch somewhere. The data has to transfer to reducer. If you compress it, less bytes of data can be transferred. Since the map output is written to a disk and transferred across the network to a reducer node by using fast compression such as LZO or Snappy, you can get performance gain simply because of the volume of data transfer is reduced. The best one is LZO and Snappy. So I'll tell you that, and also they have their own benefits and disadvantages. Let's look at here. This is what I was talking about: gzip, bzip2, LZO and Snappy. So these are the different algorithm they have used, and whether they are splittable or not. If you go with a gzip, that output is not splittable. Only one mapper has to launch. bzip2, yes, it is splittable. LZO, yes, it is splittable. Snappy, no, Snappy is not splittable. So Snappy data, that is the reason what we will do. The Snappy and LZO, as I said, they are benefited, but the Snappy and LZO we will not use as input as a compressed data. So that's why this LZO and Snappy are right. This LZO and Snappy we will not use as a input. What we will do, we will use these two, either intermediate data compression, means map output, or final output, reducer output. Because if I go with LZ1 Snappy as the input which is stored in HDFS, if you give LZ1 Snappy input data to a MapReduce, it is not splittable, but LZ1 is a splittable. LZ1 is a splittable. There is some exception for this. If the data is coming as in indexed format, yes, LZ1 is a splittable, so you can launch a multiple mappers on the LZO data. So the most popular one is these two, Snappy and LZO. Snappy is mainly used for intermediate output, a map output, or reducer output. Even LZO is also using for the same purpose. Okay, so but the compression, coming to the compression ratio, your Snappy gives a better ratio. The Snappy gives a better ratio than others. So if you look at here, they have specified what it is, you can easily understand. So your Snappy reduces, it will give compression ratio is more compared to others. Snappy compression ratio is more. You can have a look here. It's a pretty simple one, you can understand easily. Okay, it reduces so much of data it can reduce. Okay, that's it, that has been said. Okay, if you can see compressions here clearly saying that how to how to split it. If we are going with which data compression if you use, the how it will be splitted. Sorry guys, you can have a look whatever we have discussed. That information is given here. And coming to compression codecs, as I said, they are based on the extension, based on the file extension, they have their own codec classes. If it is a deflate, it has a default codec. gzip, bzip2. LZO, LZ4 snappy codecs. They have their own codecs. If you are writing your intermediate data as an output or final data as an output, final output as a compressed data, you need to specify what is the compression codec you are using. Set output compression, set compress output. You need to set this. You need to set this. What is the codec format you are using? You need to specify that. What is the codec class you are using? You need to specify that. Okay. The only changes here, because your final output you are going to compress, you have to specify that. And suppose if you are compressing only map output, let's come here. You have to specify that only map output. If you are compressing, you need to set the map output dot compress codec. Map output dot compress codec. You have to specify whether your output only map output you are compressing or final output is compressed. Suppose if you are compressing the final output, these are the two lines. Output format dot set compression to true and output format dot set compression codec the class you have to provide. But if you are compressing only the intermediate data or map output, so pretty simple, you need to you have to enable this configuration, set configuration, and configuration name is this and the values are this. For LZO also they have respect to LZO codec classes. For the snappy also they have respect to snappy classes. So you can have a look. So if you can see that in the counters, you can easily see that the less amount of the data has been read compared to no compression with the compression. So look at here, without compression, if you see number of bytes has been read from here this much, but after compression this much only. The map, the total output has been written this much, but after compression it has been written this much. So you'll see more difference. If it is intermediate data, you can see the results. Okay, so using the compression techniques, you have a very good compression. You can improve the performance, and you can also save the names space of the HDFS. Okay, so that's it, guys. About the compressions. Any doubts about the compression? Any doubts about the compression techniques? We almost done about the Mapreduce. There are few more topics are left out. I don't want to leave them, so that's the reason I'll just discuss about them as well. Any doubts? Anila, Madhu, Nagi, Debashish, Sulba. Any doubts about the compression? Okay, Anila, I didn't see this. Let me show you in the how real time we'll use the compression techniques. So that's what in the real time also the same way. Whether you want to compress, final output, or you want to compress the final output or intermediate data. Okay, so if you see that, you can see here the lazy output format we have used, and the compression also we have used. I'll show you what is the compression technique we have used. The LB enhancements will be going on, so maybe no, it is there. Let me check it. It will be there, so you can do like this. Lazy output format dot set output format class, what we have discussed before. And coming to compression, we have used LZO compression. Why I'm not able to see here? Hmm. Compression output stream. Yeah, compressed codec we have used. We have used LZO compression. So I'm just looking, maybe we might have removed it. LZO codec. Yeah, LJOP. Look at guys here. Compression codec we have used LJOP. Okay. So that's it. That has been said. Let's talk. Let's talk about what else is pending. Okay, so let me talk about what are the pending topics. We'll just see what are the pending topics we have. So, another important topic is there. That's very much important. We'll be discussing that. The pending topic is distributed cache. Distributed cache. Secondary sort. Secondary sort. Joins. Already we have seen multi-output format, which is reduce side join. There is something called map side join. We will look at the map side join. And what else? And that's it, I hope. So let me look at my is there anything? All input output we have discussed, writables we have discussed, combined input format we have discussed. Distributed cache we need to discuss. So that's it guys, only we have left out with the three topics. So yep, we can complete this week. Yeah, that's it. Oh, custom input format. We didn't discuss about the custom input formats, right? There is a one something called custom input format. Custom input format. Tomorrow we are going to discuss about the custom input format, how to write our own custom input format. We will be discussing about this, and distribute cache, secondary sort, and joins. So with that, so we will be completing a Mapreduce successfully, and complete all most of the things. Not most I mean most of the things we have covered, and custom input formats we'll discuss tomorrow, and distribute cache day after tomorrow. Yeah, I think by this week we'll complete the Mapreduce, and from Monday, with the new year freshly, we'll start with the hive. Okay, with the new year we'll start with the hive. Okay, any doubts?